Hi, this is Mrs. Myers, and today we are going to learn lesson 1.3, measuring segments. Our target today is to be able to find and compare lengths of segments. Every point on a line can be paired with a real number. That real number on a number line that corresponds to the point is called the coordinate of the point. And the distance between the 2 points is the absolute value of the difference of their coordinates, or as we see, A minus B. In these symbols, those symbols mean absolute value. So the absolute value, or their value as they are the distance from 0, of the difference, we know difference means subtraction. So we're going to subtract the 2 coordinates, the values of the coordinates, to find the distance between the 2 points. So in problem 1 here, we have the question, what is ST? Now notice, ST does not have a symbol over it. We're not talking about ST, line segment ST. We're talking about just ST with no symbol, which, if we remember, means the distance from S to T, or the length of segment ST. So we're finding the distance here. So we're going to start with our absolute value that we learned here. The coordinate of S is -4. The coordinate of T is 8. So we're going to plug that in. The absolute value of S minus T coordinates is -4 minus 8. When we do -4 minus 8, we get -12. We have to remember that it's the absolute value of -12, so the distance from S to T is 12 units. So if we try the next couple of examples here, the question is, what are UV and SV? Meaning the length of UV and the length of SV. So you, at this point, should try this on your own. Remember, you're doing U minus V, S minus V, and plugging in the appropriate coordinates. The coordinate of U is 10. The coordinate of V is 14. Absolute value of 10 minus 14 is -4. So the absolute value is 4. That's the length of UV. SV is going to be, the coordinate of S is -4 minus the coordinate of V, which is 14. -4 minus 14 is -18. And the absolute value of -18 is just 18, positive 18. So the length of SV is 18. We have here a postulate. We've talked about postulates before. Segment addition postulate is going to be a very important postulate for us to help us solve for the lengths of segments. If we have a situation like in this diagram here, where we have a line segment, in this case AC, but it's got a point right on that line segment, so a collinear point that's sort of separating that segment into sections. In that case, we're going to be able to apply the segment addition postulate, which says that if 3 collinear points are in such a way that B is between A and C, then the distance from A to B, or the length of AB plus the length of BC, equals the length of AC. So let's apply this. Now I want you to keep in mind this little acronym here, LISA. LISA is going to help us remember the steps for effectively solving the diagrams where we have missing information. It's very important to always remember to L, label your diagram with all of the information that you know. E, write an equation that makes sense from the diagram. You're not just going to write an equation that you think looks good. It has to actually correspond with the given diagram and the information. S, you solve your equation. And A, remember to go back and answer the question that was asked of you. Sometimes you have to do more than just solve for the variable. You have to plug that variable back in and solve. So this next problem, we're going to keep in mind Lisa. And we are going to take our diagram again with A, B, and C on a segment where they have it labeled here. The distance from A to B is x plus 5. The distance from B to C is x. But they tell us this piece of information. AC is 25. And we're trying to find the length of AB. So, use the given information and the diagram. And Lisa, label. Well, AB's already labeled, BC's already labeled, but this piece of information needs to be put on the diagram. So this whole length from A to C is 25. Now our diagram tells us the whole story. From here we can write our equation using the segment addition postulate, which said, if you remember back a little bit ago, we said AB plus BC equals AC. So we're going to substitute in our values to this equation, and that's going to write us an appropriate equation. AB is x plus 5. So that's AB. Plus BC is x. So here we have x plus 5 is the AB, and x is the BC. Now equals, and AC we know here is 25. So this is our equation because of the segment addition postulate. So we labeled our diagram, we wrote our equation, now we have to solve. We see like terms here, x plus x is 2x, plus 5 equals 25. And then we see that we need to isolate x, we get 2x equals 20. And then we need to divide by 2 to solve for x, and we get 10. So x is 10. Remember to go back and answer the question that was asked. AB, therefore, AB, which is labeled as x plus 5, when we plug in the 10 for x, we get AB equals 10 plus 5, or 15. Okay, so problem 2 is very similar to the first problem. You should try this one on your own. And don't forget Lisa. Label, equation, solve, answer. So go ahead and do it on your own. And I'm going to continue. When you're ready, come back and check to make sure you did it correctly. First, label the diagram. 59 is EG. So the equation I'm going to write is 8x minus 14 plus 4x plus 1 equals 59, because segment addition postulate says EF plus FG equals the whole thing EG. So my reason for this equation is the segment addition postulate. And as we know, we like to abbreviate. So now I have my equation that I can solve. I get 12x. When I combine the 8x and the 4x, I get 12x. And then I combine my negative 14 and the plus 1, and I get minus 13. And the whole thing equals 59. And when I add 13 to both sides, I get 72. Cancel out the 13s, I get 12x equals 72. So now I'm going to divide by 12 to solve for x, and x equals 6. Don't forget to answer the question, though. We have to plug 6 in to find EF. and 6 in to find FG. And we find out that EF is 48 minus 14, or 34. And FG is 24 plus 1, or 25. Okay, so moving on to some more important vocabulary here. We know that when numerical expressions have the same value, you say that they are equal. In other words, like 2 equals 8 divided by 4, or 8/4 equals 2. We use an equal sign to say these two values are equal to each other, the same value. But if two segments, two pictures, two things have the same exact length, we're not going to say that they're equal. We're going to use a different word. If two segments have the same length, we are going to use the word congruent. They are congruent to each other. And of course we have a symbol for this, and the symbol looks like an equal sign, but we put the squiggly over it. That's a congruent sign. It means it's congruent to. Now also on a diagram, it's important to recognize when the diagram is showing you that things are congruent, they use what they are called tick marks. So if I want to show that this segment AB is congruent to segment CD, I would use a tick mark on both to look exactly the same. Sometimes a double tick mark shows that they're the same, maybe even a triple tick mark, depending on your diagram. So if AB is equal to CD, in other words, their lengths are the same, have the same measure, then we could say they are congruent to each other as well. So look at this diagram. The question is, are AC and BD congruent? We are going to find the measures of AC and BD first to decide whether they are congruent, because if the lengths are the same, then they are congruent. So we're going to go back to our absolute value to find AC. We're going to do absolute value of A minus C, which is A is -2, and C is, looks like we're counting by 2's here, so C is at between 4 and 6 is 5. So we have -2 minus 5 is -7. Absolute value of -7 is 7. So AC equals 7. Now we're going to find the length of BD. Again, B minus D, absolute value. The coordinate of B is between 2 and 4, so that must be 3. Minus D is 10. Here, so 3 minus 10 is -7 again, and the absolute value of -7 is 7, so BD equals 7. So if we know that AC is 7 and BD is 7, that means AC equals BD, because they're both 7. So therefore, yes, these two segments are congruent. AC is congruent to BD. Now here we need these line segments over them because, let me rewrite that. AC, now we're talking about the segment itself, so we need that line segment symbol over it. And BD, we need the line segment symbol over it. They are congruent to each other. This says AC is congruent to BD. One more term here is the midpoint. The midpoint of a segment is a point that divides the segment into two congruent segments. So a point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect the segment. So we really have two vocabulary words here, midpoint and bisect. The point, line, or ray that does this bisecting is called the segment bisector. So line L here is a segment bisector, and it is bisecting segment AC, because you can see here that AB is marked congruent to BC. If AB is congruent to BC, then B must be the midpoint of AC, because a midpoint divides the segment into two congruent segments. So B is the midpoint, and this line L is the segment bisector. If we want to try this first example here of applying this definition, we're going to still use Lisa, but the information we're given is that Q is the midpoint of PR. They didn't tell us the whole length like they used to, like they did last time. They just told us that Q is the midpoint of PR. So that tells us that this segment is congruent to this segment, which also tells us, so that's my labeling, marking these two things congruent, PQ congruent to QR, that's the L of labeling. That helps us write our equation. Our equation is 6x minus 7, that's the segment PQ, equals 5x plus 1, because we know that if the two things are congruent, then they have to be equal. If I were going to write a reason for this equation, it's the definition of midpoint. They told us midpoint. We used what we knew about what midpoint means to write this definition. So 6x minus 7 equals 5x plus 1. Now we're ready for our S and solve. I'm going to subtract 5x from both sides, and I get x. Minus 7 equals 1. I'm going to add 7 to both sides. I get x equals 8, and I've solved. Don't forget A and Lisa. I'm going to answer the question. PQ, QR, and PR, we need to plug in 8 into what we know here. So 6 times 8 minus 7, 48 minus 7 is 41. And 5 times 8 plus 1 is 40 plus 1 is 41. So we have 41 and 41. They ask us PR, that's the whole length. Segment addition postulate tells us PQ is 41, QR is 41. Altogether, it must be 82. Okay, the rest of the problems here, I'm going to put on a different video. And thank you very much.